Hello everyone, hope you all are doing well. The Stable Diffusion is another text-to-image model similar to many other text-to-image models such as OpenAI, DALL-E, DALL-E 2, Google Imagen, OpenAI, Clip, and many more. So like any other new technology, I decided to give a quick test drive with the Stable Diffusion AI model. And this video has everything what I have done. So first I visited at the Stable Diffusion GitHub repo to learn more about the technology behind the model related to its training, output generation, anything in between. Next, I visited the Hugging Face model card to learn more about the models which are available in the public domain and can be tried. I found that the version 1 model is available with its 4 revisions. I also found that a Stable Diffusion model also has its Hugging Face space where I could give a quick try. I looked at Hugging Face space Gradio application and checked its performance by using some of the text prompts. While I'm connected with the MidJourney Discord server, I decided to compare the results between the MidJourney as well as the Stable Diffusion AI models. The Stability.ai organization is also working on a project named DreamStudio, and because I had access to DreamStudio Beta, so I also tried the Stable Diffusion AI model at the DreamStudio. Finally, I decided to build my own Stable Diffusion application at Google Colab by downloading the model and give it a quick try. I downloaded the Stable Diffusion latest AI model at Google Colab and build the full end-to-end application by using the diffusion module as well as the Hugging Face transformer. At last, I also built the full Gradio application on top of the Google Colab, similar to Hugging Face space. After I completed my exercise, I made the Jupyter notebook also available at my public GitHub repo for anyone to try. So I think this introduction is good enough for us to get started. Stability.ai is making really big news in the AI community by introducing their Stable Diffusion model, which is actually a latent text-to-image diffusion model, and its architecture is very similar to Google Imagen. Google Imagen text-to-image AI model is recognized for its photorealistic images and very high level of language understanding, as seen through these few examples. Coming back to a Stable Diffusion model, there are few aspects which are notable around Stable Diffusion. First, this model is very lightweight and it is designed to run on about under 10 gig of GPU RAM. Even when the Stable Diffusion model is trained with really very large dataset, still this model is relatively lightweight and designed to run under 10 gig of GPU RAM. The Stable Diffusion model is also conditioned on the non-pooled text embeddings of the OpenAI Clip VIT L14 text encoder. And with the Stable Diffusion, you can actually pass the text prompt along with initialized image, and the model is going to generate the final artwork based on your input text and the given image as seen here. So here is the text prompt and here is the input image, and that's the final output. Here is another output for the same input. So if we would want to use this model and learn more about it, we can visit at Hugging Face and look for the Stable Diffusion card. The model card is here. So here is the Hugging Face where the Stable Diffusion model card is added. Looking into the model card, we could see that the current progress related to the models. If we would want to try for this Stable Diffusion model by visiting to their space, and we can use the same text prompt While our request is in queue, we can take a look at this DreamStudio Beta. I already have access to DreamStudio Beta, so I will be opening it. And here is the prompt. So I will be using the same prompt here with some. We can also compare the Stable Diffusion results with the MidJourney. Here I have access to MidJourney Discord channel, and here you could see there are various samples of MidJourney. So we are going to select one of the text prompt from the MidJourney and apply it to our Stable Diffusion. This is what Stable Diffusion model has provided comparative to the results from the MidJourney. We can give one more quick try. Looking back to the Stable Diffusion, this model is definitely generating photorealistic landscapes based on our text prompt. So as of now, we have tested this model at Hugging Face space. We have also checked this model at the DreamStudio, and now our next step would be to let's try to use this model in Google Colab. Because we are already looking at the Hugging Face space, we can look into the files and version, and here we can open the app.py, and this is the code which actually runs the overall Hugging Face space code. So looking into this model, we could actually build our Google Colab code. So first thing first, let's give the credit from where we are porting the code. Next, we are going to look into the code, and as you see here, these are the important modules this code is going to be used. So these are the modules we needed. So first we need to make sure that we install the diffusers, because I'm using a pre-built Colab environment, so that's diffuser is already there. We need to have the datasets. Datasets are there. And because we are using the Hugging Face transformer, so even when it is not listed here, we need to make sure we have installed that as well. Transformers. Okay. So with these three important packages were needed for us to install, we have installed them. Gradio is not needed for this application, so we have removed it, and looks like everything is okay so far. In the next step, we are defining our model ID. So here is the model ID, and here we are using the device as CUDA. So I will separate them into separate cells so we can change them independently. Because our runtime has the CUDA supports, that's why we are using the CUDA. If you do not have CUDA, you can set this to CPU. Let's copy this code and study it. So here what we are trying to do is that, like for any transformer, this is the Stable Diffusion pipeline which is built on top of Hugging Face transformer pipeline. That's why when we have used the diffuser which is coming out from the Stability Diffusion team, we made sure that we have also installed the transformer to complete that dependency. So a couple of things we need to do. Because we are not running this code in the Hugging Face, it means we have to make sure that we have a still connection from this runtime, which is the Colab, to the Hugging Face environment. Okay. So Stable Diffusion pipeline, and we are loading the model, which is this model authentication token. Internally, when this application is running here, it uses the true, but because we are running this outside the environment, we have to provide the token. Revision is FP16. Torch type, we are using the float 16 point, the torch tensors. So the only big difference is that we need to take this and we have to provide the use auth token. Hugging Face, once you sign up, and in the tokens area, you have two types of token. One is user access token, second is organization API token. Make sure do not select the organization token, select the test token. If you do not have, you can make your new token. So this is the token I will be using. So it's in my memory right now, and I will be using my token here. When I do not need, I can delete this token and I can create a new token. So that's why I can expose this token in this demo. When I will run, this will generate the pipe object. We will make sure that that pipe object is actually initialized on the CUDA device. So I will run this code. So at this point, as you see, that pipe is the stable diffusion pipeline. We can also look into the config. Here is the pipe config where you could see this is a variational autoencoder diffuser autoencoder. So this is the class and it has a text encoder. It uses the clip text model tokenizer object which belongs to stable diffusion pipeline. However, you did not see that the model was downloaded. Reason we did not see, because this machine already had the model downloaded, because I'm using a pre-built environment. I can show you ls-la. Here you see there is a Hugging Face in my cache diffuser. Here is the model and all the models are downloaded here. If you would really want to see the model is downloaded, what you could do is that you could remove the model itself from here. So we will remove this diffuser folder from Hugging Face. Everything is cleaned up. It means we can go ahead and we can relaunch this cell and you will see that model is going to be downloaded. So while this model is downloaded, let me make sure and I comment this RM line so accidentally we do not delete our model, which will save significant amount of our time. So model is downloaded, our pipe object is back, pipe dot tokenizer. We can look into what is our tokenizer. So remember, every time whenever we are using a pipeline, especially related with text specific tasks, we must need a suitable tokenizer, and that is very important. And here we are checking that what is the tokenizer associated with our pipeline, and here is the tokenizer. You could see that's the path is shown. That's the tokenizer vocabulary size, and you can actually validate that tokenizer also by just taking this path. Here is the tokenizer. You could see that this is the tokenizer files. At this point, looks like we do have everything really needed for us to start the actual work. We're reading the prompt and generating the image. This is the app design. This app has few things. Prompt, button to support on-click event. This is the place where the result will be generated. Some of the advanced option where you can say how many images you would want to generate, how many steps you would want to use, guidance scale, as well as the seed. So you can set seed as well. And that is what is being supported by this code. That's what you are really seeing. So this is the infer method. I will be taking this and I will be bringing that method to here. Next, if you are new to Gradio, usually what happens is that this whole UI is being supported by the code. And if you look into, the real action is actually happening in here. Here is the function, launch this function, and here are the input, pass these input. And when this function is going to run, generate the output in this object. So that is real meat of Gradio launcher. So if we would want to run this code outside Gradio, we just really need to care this. So this is the method. So we have prompt, we have samples, we have steps, we have scale, and we have seed. This example, we are not passing the sample, so sample is really do not needed. So we just really need to create the prompt. So let's create the prompt first. We also need a seed. Let's set up the function. So this is the function. I'm gonna be taking this function. If we are running this app locally, we do not need this. We can remove this. We also do not need samples here. We have steps, remember. So steps are between 1 to 50, 20. We also need a scale. A scale equals to, looking into the scale, 10.5. So we have all these 4 parameters: prompt, steps, scale, and seed. Here we are not using the samples, just pass as the prompt here. This code uses not safe for work related detection. Just to follow as guided, there is a unsafe.png. Download this image and copy this image to our content section. So as you could see that I have already uploaded the unsafe.png, and this unsafe.png is in content folder. So we have to proper path. I think that's all. And at this point we can pass these 4 parameters. The output will be the img out, and remember the return is a list of output images. Okay, let's run it. Oh, seed, we made mistake. Seed is okay. Our code is running. Code is completed. We can look into what is image out. Image out is a list of pill images. It means we can take image out and we can say what is on 0, and here is the image depending on what we have asked. We have asked for Pikachu is running and horse, so Pikachu is actually look like the horse. Now if you would want to change it, we could actually make this prompt. A robot is helping a dog in the lake. Okay, so now we have 2 prompts. Let's run again. We can look into the image out. There will be 2 results. So this is the first one is the same. The second one, and here is the robot, lake and dog. So you got an idea that how we took an existing application and we have made it work in the Google Colab. In the next step, what if we would want to actually build the same Gradio application in the Google Colab? That can be done also very easily. So in the next step, we are going to just this CSS all the way to here, and let's copy it here, everything. So make sure we have Gradio. So we are importing Gradio. One more change we could make here, because whenever you are going to use this sample prompt, text prompt is going to generate the 4 images, which will take time. We can convert that to 1. Here is our function example, which is calling the infer and text samples steps. So here you see that we do have these samples here. We just call it inference new function. So we have make changes, correct changes, infer new here. So we need to make sure that the infer new is being called properly here. We really do not need this footer license for now. We can remove this section, and then now grhtml is removed, and we could take the function which we were using and call it inference new and pass the samples. I think that's all we have done. So this is our inference new. Here is the full code, and we are dead because of we are exceeding our CUDA memory. CUDA is already red here. Okay, we could restart the runtime. So all our local variable will be lost, but our cache will still gonna be saved. So I have restarted the runtime, and I'm also going to clean the outputs. So we do not really need to install any of these packages. If we try to import all these modules, it all is all going to work. Setting it up. At this time, we don't really need to download our models because they are already available in the cache. Our objects are ready. Tokenizer is all set. We do not need this code. I'm going to delete it, and I will just leave this thing as it is. I will not use, and I will just come back to Gradio. So this is our infer new method, importing Gradio, and now we are launching the Gradio app. Let's see. At this point, the code is still running. Looking into here, you could see that memory is definitely at the edge. All 5 sample images are generated. Here is our Stable Diffusion Gradio app. We can launch this to outside browser. Here, if we could select image, here you could see the 1 image. If we select this, the image is loaded, and these images are being loaded from the cache because we have already created 1 image But if you would want to use our own text prompt, so we can say a small cabin on top of just mountain in the style of castle. A new image is going to be generated by using our model. While your application is running to generate the new image, you can check the status of the GPU. So this is how you could create your own Gradio application by using the Stable Diffusion model. The code which we have covered in this Jupyter notebook is available at GitHub, which you could follow very easily. So that's all I had for you in this video. I hope you have enjoyed the content and learned something new. I do appreciate your time and I'm looking forward to seeing you in my next video. Until then, thank you so much.